Good morning once again to all of you. Welcome to the organic chemistry class, chapter 8. Today is the 11th day, day 11, and today is 5th of October 2021. So let us begin with the chapter, continue with the chapter organic chemistry. Till the previous class, I had completed uses of alkene, ethene. Today, I am going to begin with alkynes. Alkynes. The third homologous series of hydrocarbons, which are called alkynes. And the alkyne which you see on the screen, it is called ethyne. It is called ethyne, and commonly it is called acetylene. Acetyllene. Commonly it is called what? It is called acetylene. Remember that. Okay. Now, now the IUPAC names of some simple alkynes. Two carbon atoms, it is called ethyne. Three carbon atoms, it is called propyne. Four carbon atoms, it is called but 1-ine, depending upon the position of the triple bond. So these are some simple IUPAC names of alkynes. Okay. Now moving further to the alkynes ethyne in detail. The alkyne which is there in our syllabus to study, it is called ethyne. Now alkynes, what are alkynes? Alkynes are unsaturated aliphatic hydrocarbons. Alkynes, alkynes are unsaturated. Unsaturated means containing double bonds. That means it is not saturated, it is unsaturated. You can add some more hydrogen atoms in it by breaking the multiple bonds. Alkynes are unsaturated aliphatic hydrocarbons. Alkynes are unsaturated aliphatic hydrocarbons. You must remember this. Okay. And then they contain a containing a carbon carbon triple bond. There is a triple bond. Alkynes, they have a carbon carbon triple bond. Then moreover, alkynes, they have a general formula. The general formula of alkynes is general formula of alkynes is CnH2n minus 2. This is the general formula of alkynes. Okay, this is what you have to remember. Now the next thing that you have to remember is reactivity. Remember, alkynes are more more reactive than alkenes and alkanes. Now this reactivity is due to the presence of carbon carbon triple bond. Okay, the reactivity of alkynes, the high reactivity of alkynes is due to the presence of carbon carbon triple bond. And this carbon carbon triple bond, this bond over here, it is called acetylenic linkage. It is called acetylenic linkage. So just because there is a carbon carbon triple bond makes alkynes more reactive than alkenes and alkanes. Okay, this is what you have to remember. Very important thing. Now, after that, let us move to the preparation. Let us move to the preparation of ethyne. Preparation of ethyne. Now, preparation of ethyne can be done by in the lab also. There are general methods also. So, first one, preparation of ethyne. The formula of ethyne, it is C2H2, two carbon atoms, two hydrogen atoms. So in the lab preparation, lab preparation, lab preparation of ethyne, it is carried out from calcium carbide, from calcium carbide. Now this calcium carbide is available locally in the local market, in the hardware shops. When you go to buy calcium carbide, you have to ask them carbide. They will not understand what is calcium, but you have to ask them carbide. So they'll give you a white colored irregular shaped solid substance, okay, and that is calcium carbide. So that is how it is available in the market. Now the reaction over here, calcium carbide, CaC2. The formula of calcium carbide is CaC2. When calcium carbide is treated with water, it is treated with water, and the reaction happens to give ethyne C2H2 plus calcium hydroxide is formed as a byproduct. So this is ethyne C2H2. So this is the equation for the lab preparation of ethyne. So here calcium carbide, it is reacted with water, okay, cold water. This water has to be cold, okay. Now calcium carbide, what do you call this, ethyne, it is collected by downward displacement of water. It is lighter than air, density is less than air, so it is collected by downward displacement of water, okay. Now, so this is the lab preparation of ethyne. Now this equation you can remember in this way also, the structural formula way. Calcium carbide, this is the formula of calcium carbide, the structural formula of calcium carbide, reacting with two molecules of water. So HOH, HOH. This is cold water. Okay, so when the reaction happens, okay, here this calcium, it detaches from this carbon-carbon triple bond and combines with the 2OH to give calcium hydroxide, COH twice, and then this hydrogen and this hydrogen attaches over here to the carbons. Okay, so it forms HC triple bond CH plus calcium hydroxide. So this is how we have to try to generalize the lab preparation of ethyne from calcium carbide. The other method of preparation of calcium carbide is from from 1,2-dibromoethane. Okay, it is called dehydrohalogenation reaction. So the next method, it is a general method, and it is prepared from 1,2-dibromo 1,2-dibromoethane by the dehydrohalogenation reaction. Dehydrohalogenation reaction. So this is the general method. So by using this method also we can prepare ethyne. So let us look at the equation. So 1,2-dibromoethane as a formula, CH2Br, CH2Br. This is 1,2-dibromoethane, or it is also commonly called ethylene dibromide. So this compound, it is called 1,2-dibromo. It is called 1,2-dibromoethane. 1,2-dibromoethane. So look at that, two carbons containing one bromine atom each. So 1,2-dibromoethane. Okay, it is reacted with alcoholic potassium hydroxide. Potassium hydroxide is alcoholic. It is reacted with alcoholic potassium hydroxide. Okay, and the reaction mixture is boiled. It is boiled. So upon boiling, there is, removal of hydrogen also, removal of halogen also. So one hydrogen each from the two carbon atoms and one halogen each from the two carbon atoms are eliminated. They are removed, and that's how we get ethyne. CH triple bond CH plus twice KBr plus twice H2O. So this is also the general method for the preparation of ethyne. Okay. Now there is another method also for the preparation of ethyne from methane. That is, I can name it as C. From methane. From methane, you can prepare ethyne from methane by thermal decomposition, or you can say pyrolysis. So here methane, we take methane CH4, okay, and subject it to high temperature around 1500 degrees Celsius. Okay, remember this one is a general method. This one is a general method, and we know methane, it is a natural gas. Okay? So when you subject methane to 1500 degrees Celsius by applying an electric arc, by applying an electric arc, so this methane gets converted, okay, to ethyne, HC triple bond CH, and dehydrogenation reaction. That means removal of hydrogen. So this is our ethyne. So these are the methods of preparation of ethyne. The first one was lab. The second one is also a lab method, but number C, it comes under a method which is called general method of preparation of ethyne. Okay. Then after this, let us move ahead to the physical properties of ethyne. Physical. Uh, Physical properties of ethyne. Physical properties. Physical properties of ethyne. Point wise. Let us go one by one. The first physical property of ethyne is with respect to nature. Ethyne, remember, ethyne is a gas at ordinary temperatures. At ordinary temperatures, it is a gas at ordinary temperatures, slightly lighter than air. Slightly lighter than air. So remember that. Because we know air vapor density is 14.4. Okay. And ethyne, if you look at the formula C2H2, 24 plus 2, 26, 26, half of 26, 13. So vapor density of ethyne is 13. So it makes ethyne lighter, slightly lighter than air. So that is the first physical property of ethyne. It is a gas at ordinary temperature and it is slightly lighter than air. That is the first physical property. Then next one, number 2, with regard to color and odor, ethyne, it's a colorless gas. Ethyne, ethyne is a colorless gas. It is a colorless gas. Colorless gas, and it has a faint garlic. You know what is garlic? Ethyne is a colorless gas. It has
Yes,
a
sir.
faint. What is garlic in Nepali?
Lawson,
Lawson, yes.
we
Adwa,
call it.
Not
Elosun,
adwa.
Elosun.
Adwa is ginger.
Yes,
Adwa
ginger,
is
yes, sir.
ginger.
Yes,
Okay.
sir.
Garlic is lawson. So it has a faint,
Adwa.
light garlic odor. Okay. That is the second physical property of ethyne. Then moving to the third physical property of ethyne with respect to solubility. Remember that it is very slightly soluble in water. So I'm writing it down. Ethyne is uh, very very slightly soluble in water. Soluble in water, but it is soluble, readily soluble, soluble in organic solvents, soluble in organic solvents like acetone, solvents like.
So then is it present in garlic?
It is not
You think?
present in garlic. It is not present in garlic. It has a faint garlic-like smell. It is not present in garlic. Okay, remember that. Am I
It
clear?
just has a smell of
Yeah, it just has the smell of faint
this
garlic
one.
smell. Okay, it is not present in garlic. Okay, now these are the three important physical properties of ethyne. Okay, no need to go through the boiling point and melting point of ethyne. Okay, now after this, my dear boys, let us move ahead to the chemical properties of ethyne. So I will go to the next slide now. I'll go to the next slide. Uh, the chemical properties. Okay, so let's move ahead to the chemical properties of ethyne. So chemical properties properties of ethyne. Whenever we talk about chemical properties, we are talking about chemical reactions of ethyne with different molecules, compounds, elements, whatever. Okay, so all the chemical reactions come under chemical properties. Okay, so remember, since ethyne it has a carbon triple bond, so ethyne will readily undergo reactions which are called addition reactions. So remember that ethyne is an alkyne containing a carbon triple bond. That's why it will undergo it will undergo addition reactions most readily. It will undergo addition reactions. It will undergo addition reactions most most readily. Okay, so this is important point to remember. Ethyne has got a carbon-carbon double bond, a triple bond. That is why there will be breaking a bond and making of new bonds. That means you can add something to ethyne. You can add hydrogen, you can add halogens, you can add haloacids, you can react with ozone, addition of oxygen. Okay, we can oxidize it by using cold dilute potassium permanganate. Okay, we can react this ethyne with ammonical cuprous chloride and ammonical silver nitrate solutions. Okay, so these are all the important chemical properties of ethyne. So let us learn the first one. The first chemical property of ethyne, it is called catalytic. It is called catalytic. It is called catalytic hydrogenation. Catalytic hydrogenation. When I say catalytic hydrogenation, I mean addition, reaction with hydrogen in the presence of a catalyst. So that is a word catalytic over here. So a catalyst is a must over here. So here, let us draw the structural formula of ethyne. HC triple bond CH. So that is ethyne. So when it is reacted with hydrogen in the presence of a catalyst nickel at around 300 degrees Celsius, it gets first converted to this ethyne gets first converted to ethene first in the first step. The triple bond breaks into a double bond. So we get a double bond now between the two carbon atoms, and then one hydrogen here, one hydrogen here. Okay, so this is ethene. This is ethene. Now further if you hydrogenate this in the presence of nickel catalyst at 300 degrees Celsius, this ethene now gets converted to ethane. So the formula of ethane is like this: HC H H, the double bond converts into a single bond, okay, and it becomes ethane after the addition of hydrogen. So it becomes saturated now. This is ethane and it is saturated hydrocarbon. So this reaction, it is called this reaction it is called catalytic hydrogenation. It is called catalytic hydrogenation. And hydrogenation of alkynes, hydrogenation of alkynes, it is carried out in the presence of catalyst nickel, and the temperature which is necessary, remember, it is 300 degrees Celsius. Okay, that was the first chemical property of ethyne. Now moving to the next chemical property of ethyne, which is called halogenation. Okay, reaction of ethyne with halogens. So here number B, halogenation. Halogenation, halogenation of ethyne. Ethyne, that means I can react ethyne with halogens like chlorine or bromine or iodine. We are not going to use chlorine due to its very high reactivity. Okay, the reaction may be highly exothermic, so we avoid the reaction of ethyne gas with fluorine. Rather, we use chlorine or bromine or iodine in inert solvents like either carbon tetrachloride or alcohol medium. Okay, so first one, the first example over here, halogenation of ethyne, is reaction of ethyne with chlorine. This is ethyne. So I react this ethyne with chlorine, Cl2, chlorine, in an inert solvent. That means the ethyne has to be dissolved, it has to be put into an inert solvent like carbon tetrachloride. So here there will be, breaking of the triple bond into a double bond and addition of two chlorine atoms to either of the carbon atoms. So here the triple bond becomes a double bond, okay, like this. One chlorine to first carbon, another chlorine to the other carbon. Okay, so this can proceed further. If I continue to add chlorine in the presence of inorganic organic solvent, that is carbon tetrachloride, so this double bond will break down into a single bond, and then that's how we get hydrogen, carbon, single bond, carbon, hydrogen, and altogether chlorine atoms on the two carbon atoms. So this compound is called 1,1. This one is called 1, 1, 2, 2 tetrachloroethane. It is called 1, 1, 2, 2 tetra. Tetra means total chlorine atoms is 4. So that's why it is called tetra. Tetrachloroethane. Now, if you look at this one containing two chlorine atoms, this compound is 1, 2 dichloro. It is called 1, 2 dichloroethene. Ethene, E-T-H-E, E, and ethene. Okay, so this is the reaction of the halogen chlorine with ethyne to finally produce tetrachloroethane. I can even react, instead of chlorine, I can use bromine also. So here, let us do the reaction with bromine. Reaction of ethyne with bromine. So I will write down ethyne first. The structural formula of ethyne. Okay, ethyne with bromine, Br2, in the presence of CCl4. CCl4. So in the first step, we get a disubstituted product. We will get HC double bond CH, one bromine here, another bromine here. Okay, and again further bromination, addition of bromine in the presence of inert solvent carbon tetrachloride. The double bond breaks down into a single bond and we get HC single bond CH, and then total 4 bromine atoms. 4 bromine atoms like this. So this compound is called 1, 1, 2, 2, tetra bromo. Tetra bromo. It is called tetrabromoethane. Okay. Now this one is called 1, 2 dibromoethene. 1, 2 dibromoethene. Okay, so this is the second reaction for the halogenation of ethyne. There is one more by using iodine. if I react ethene C2H2 with iodine over here, the reaction of course takes place with lot of difficulty, because there is no more further substitution after the two carbon or two what you call after the two iodines have attached to the two carbon atoms, and there is a double bond over there. So reaction happens with lot of difficulty, and this reaction is carried out in a medium of ethanol, in a medium of an alcohol which is ethanol. So we use alcohol over here. So ethyne reacts with iodine in alcohol medium to give C2H2I2. So this one is ethylene acetylene diiodide, or we can say 1,2-diiodoethene, 1,2 diiodoethene. Okay, the reaction stops over here because the reaction happens with a lot of difficulty. So this is the second chemical property of ethene, reaction with halogens. Now moving to the next one, that is number C. Number C, it is called reaction of ethyne with acids, halogen acids. Okay, so I'm writing it down. Reaction of ethyne with halogen acids. Halogen acids. So here the reaction of ethyne with halogen acids takes place in this way. Halogen acids are what? Hydrochloric acid, hydrobromic acid. So here the halogen acids normally used are either hydrochloric acid or hydrobromic acid. We normally do not use hydroiodic acid. So let us use these two acids only. Okay. So the first equation is for the reaction of ethyne with hydrobromic acid. So I'm going to use HBr. HBr in the first step. So here when we react with HBr, the hydrogen goes to one carbon, the bromine goes to the other carbon, and the triple bond, it breaks down into a double bond. So the first product which is formed is like this: HC double bond CH, over here H and over here Br. This compound is it's called bromoethene. Bromoethene. Further, if I further react with HBr, hydrobromic acid, now the bromine goes to that carbon containing the bromine. So it will go here, and the hydrogen will go to the first carbon. So here I will get HC single bond C H, and then over here two hydrogen, over here two bromine atoms. This compound is 1,1 dibromoethane. It is called 1,1 dibromo 1,1 dibromoethane. That is how you get the reaction of ethyne with the halogen acid, that is hydrobromic acid, HBr. Okay. Then this reaction, note that it happens at room temperature normally. Okay. Then the next one under reaction of ethyne with halogen acid is reaction of ethyne with hydrochloric acid. So that's the equation over here on the screen: HC triple bond CH with HCl, hydrochloric acid. So as I've told you, like the previous one, the hydrogen will go to this carbon, the triple bond will break into a double bond, the chlorine goes to the other carbon, like this. So we happen to see that we get over here like this, a double bond here C H, and over here Br. This is 1 bromoethene. This chloroethene, sorry, this is Cl. This is Cl. Okay, chloroethene. Further reaction with HCl will give me HCH3, single bond CH, one Cl here, another Cl here. Note that over here, this chlorine is attaching to that carbon containing the chlorine only, because of a certain rule which you'll be learning in class 11 only. The rule is called Markovnikov's rule over here. Okay. So we learn about that rule in class 11 in detail. Okay. So the chlorine goes to that carbon containing the chlorine, and the hydrogen goes to that carbon containing the hydrogens. Okay, so that's, and the double bond breaks into a single bond. So this compound is called 1,1 dichloro. Dichloro. It is called 1,1 dichloroethane. So that is your third chemical property addition reaction of halogen acids with ethyne. Okay. Now, moving further to the next chemical property of ethyne, number D. Number D is reaction of ethyne with ozone. Reaction. Reaction of ethyne with ozone. 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 Okay. So here, let us see conditions. At ordinary temperature. Temperature is ordinary. It has to be ordinary room temperature. So here, if you take ethyne, HC triple bond CH, and react it with ozone, O3, ozone. Okay. Now here, the product formed, it is an ozonide. It is an ozonide. The triple bond breaks into a single bond like this. HC, single bond CH like this, and then oxygen here, one oxygen here, and then one oxygen on the top like this. It's an ozonide. It is an ozonide. So now this is called acetylene ozonide. It is called acetylene, ACETYLENE, acetylene ozonide, OZONIDE. It is called acetylene ozonide. Now this compound acetylene ozonide, if you further decompose by using zinc distillation, if you decompose by using distillation zinc, then it forms a very important compound which is called glyoxal. It forms a compound which is called glyoxal. The formula of glyoxal, it is a dialdehyde, dial. It forms a compound CHO, distillation with zinc. So this is the reaction of ethyne with ozone, which is very, very important. You have to know that. Okay. So this is the first, second, third, fourth chemical property of ethyne. Okay. So try to remember this wonderful, beautiful formula over here for acetylene ozonide. Okay. After that, if it is heated with zinc metal, which is called decomposition by using dry zinc. Okay. So this is going to break down into aldehyde CHO. This is the bond which is breaking. Okay, it is going out, and here it is forming dialdehyde. Okay, now the next one is number E, which is called oxidation by using say cold and dilute alkaline potassium permanganate solution. So oxidation of ethyne by using uh, dilute potassium permanganate solution. So this potassium permanganate is an oxidizing agent. Okay, it is called Bayer's reagent. It is called Bayer's. It is called Bayer's reagent. Remember that. So when you react this ethyne HC triple bond CH with alkaline potassium permanganate, which is going to provide 4 nascent oxygen. Okay, then this ethyne gets oxidized, to a very, very important acid which is called oxalic acid. It is called oxalic acid. So this reaction becomes important for all of us. Okay, remember. So ethyne, when reacted with cold dilute potassium permanganate or simply dilute potassium permanganate solution, gets oxidized to oxalic acid. Oxalic acid is what? Ethane 1,2-diet acid. Okay, that is what you have to remember over here. Now, otherwise, if you don't use this Pierce reagent, you can simply burn ethyne, which is called combustion. The combustion part is like this. Ethyne, it's a hydrocarbon. So combustion of ethyne will always result the formation of carbon dioxide and water vapor. So here, if I take ethyne C2H2 plus oxygen, 5 molecules, it will give me carbon dioxide and water vapor with a lot of heat energy which is given out, an exothermic reaction. Okay, now remember over here, ethyne burns in air with a sooty flame. The flame, it is a sooty flame. It is a sooty flame. Lot of soot, lot of carbon dust comes out. That's a sooty flame. but in excess air it burns with a brilliant white flame. Okay, so remember, if there is just sufficient air, it burns with a sooty flame. But if you have plenty of air or oxygen, then it burns with a brilliant white flame, giving out a lot of heat energy. Okay, so this was the first, second, third, fourth, fifth chemical property of ethyne. The next one is number F, the most important chemical property, most important, most important chemical property of ethyne, which I will not discuss today because I need to explain this properly. So since there is less time, I will stop my class here only. I'll discuss this most important chemical property of ethyne in the next class, in the coming class. Okay, so with this, I would like to end my class over here. But before leaving the class, I will record the attendance. So therefore, please hang on, remain over there only. Do not go away. I will record the attendance. Then only I will leave, and then you may join the next class. Okay. So here we
Thank
are.
you, sir.
Yes, sir.
Welcome, welcome. Okay. So wait. Let me record the attendance. Then only you can leave the class. So I can see Binayak is a very glad fellow,
Yes, sir.
very happy fellow.
Thank you, sir.
I'm talking about Vinayak and another Vinayak also. Today Dakshi is not speaking at all. I think he must be very very sad. He's
Present.
Good
he's
morning,
very very
sir.
sad. He's very very sad. Thank you so much. Have a nice day.